So in this video, we are going to leverage the large language model, that is LLAMA3 model, using Ollama, and we are going to build a PDF RAG application that you can chat with your PDF locally. So we are going to use the Nomic-embed text model from Ollama and the Chroma DB as the vector store. So we are utilizing the Chainlit as a framework for this purpose. Right, so the Llama 3 is a model series developed by Meta, the Meta team, and it comes in two sizes. So we have the 8 billion and 70 billion parameters. So they are available either the pre-trained or the instruction tune. So the Llama 3 instruction tune models, they are optimized specifically for dialogue and chat applications. So it consistently outperforms many of the existing open source models across different benchmarks, right? So as you can see here, the Llama 3 instruct model performance, you can see right here, they outperform most of these open source LLMs as compared to JAMA, Mistral, 7B, Instruct. So within all these benchmarks, you can see the Meta being on top of the chart, right? So let's see here the same with the human evaluation. You can see comparable to the Instruct, the Cloud, Sonnet, the Menstrual Medium, is GPT 3.5 as compared to the 70 billion. You can see it is on top compared when you look at the human evaluation. All right, and yeah, we have the pre-trained model performance as well. Okay, so let's look at the Nomic text embedding. We are utilizing the Nomic text embedding to be the to create the embeddings, and it also proves to be or has a higher performance. So it is a large context-length text encoder, and it surpasses the OpenAI text embedding, that is the 002 and the 3 small. Right, so it performs on both short and long context stacks. And so already have videos that implements different open source LLMs to build RAG applications. All right, so you can go in there and check it out. Okay, so so let's look at the requirements for this application. So you should have the minimum requirements should be a 10 gigabyte of RAM on your local machine. All right, and so if you want to install Ollama, so let's look at the installation. So you go to ollama.com. All right, so you go to ollama.com, it should take you here and you see where there is download. And depending on your system, you can check whatever your system, the Mac OS, the Linux, the Windows. So I already have this installed. So when you check it on, you click on it and it's pretty straightforward to install. And when that is done, you should have this icon means that is running on your local machine. Okay, so I'm going to take you through the architecture of how this works. Okay, so we are going to upload PDF document and we are going to create chunks from this document. We split that into chunks, individual document, and we are going to feed that to embeddings. So it means that we are going to convert those texts into embeddings so that can be fed into the large language models. All right, so embeddings is nothing but the representation of these texts into numbers. So we are going to use the Nomic-embed text to be our embedding. Okay, so when that is done, we push that into the vector store. So we store these embeddings into a vector store. So we are using the Chroma DB to store our text. Okay. All right, so this is where we are going to have the knowledge base, okay, so that when the user asks any question, it converts into embeddings and it tries to create an understanding of the question and find similarities in the vector store, that is the knowledge base. And it then performs a rank, so you can rank the answers. Let's say you can rank it to like top 3, top 4, And when that is done, it pushes to the LLM. So the LLM, we are using the Llama 3 model. And the answer here is passed to the user. Right? It's pretty straightforward. Right. So I've already run this. It seems to be a great model, getting great answers. All right, so I use the mental health data to do that. So I'm going to walk you through how I actually build this. We're going to walk through step by step. All right, so here are some of the highlights of the answers. So what is definition of the concept of stigma? According to the context provided, definition of stigma is stigma. I really like the way it outputs the answers with the sources attached to it, which is awesome. And I also said ask what are the consequences of stigma, and it's spitting out the answers. The consequences of stigma can be far-reaching and devastating, which is awesome, and it's giving out the resources to the answers. Right? So I'm going to walk you through how you can build it step by step, and it is 100% on your local machine, so you don't want to have to worry about privacy and leaking out information. Okay, so let's get into it. We have our requirement and we have our app.py. All right, so I've already created an environment. So I'm going to walk you through how to run this on in your VS Code. Okay. All right. So before we do that, let me create a new terminal. Kill this one. All right. So I've already created an environment. So if you want to create an environment, you're going to say Python -m So when you hit enter, it should create an environment just like this one. All right, so all I need to activate, so I'm going to go here, I'm going to say env/script/activate. When I hit enter, it creates an environment just like this one. All right, so the next thing is we need to install a requirement. So we need to install Chainlit. So I'm using this version 1.0.20 and LangChain community Pi PDF Chroma DB. Okay, so I'm going to comment this one out. Okay, so we need to install this one. So here you say pip install requirement txt. So when you hit enter, it should install all these packages. I've already installed that, so clean it up. All right. So the next thing is to go to app.py. All right. So in here, put this down a little. In here, we import Pi PDF2 to interact with our PDF files, and we import our Ollama embeddings to create the embeddings. So we are using Ollama. So in here, we are using for the embeddings, we are using the Nomic-embed text. All right, we've already discussed that. And the recursive characters text splitter to split the text, Chroma to store for the vector database, and the conversational retrieval chain to create our chain to retrieve answers, and the Ollama. So this is where we're going to run the model. So we are using the Llama 3, and we want to add some memory capability. So we are using the chat message history and the conversational buffer memory. All right. So we import the Chainlit and CL, and that is the framework. So on chat, we are starting the chat. So we call this file. So we say none because we initialize variable to store the uploaded files. So we call it files. We don't have any file here, so we say none. So this block helps you or enables the user to upload files. So we upload the PDF files and we add context like please upload a PDF file, and it's a PDF file. So the max size is 800. So if you want to add a max size, okay. Right, so the max file is 10, and timeout is 180, and so this is timeout. This is to set a timeout for the user response. Okay, so we want to get the file that we uploaded, right? So we call it file, and we want to print the name of the file, and we will send an image with the local file path. So there's just an image that was going to display when you run the application. I'm going to show you how that works, and we import the user. So we inform the user that processing has started. So we pass this processing into the content, and we pass the element that we've created here. We pass it into the message. All right. So when the user enters or runs the upload file, it will be displayed as processing, and the image will be displayed as well. So we read the PDF file. So we use the PDF file 2, the PDF file reader, PDF reader. So we pass the file path and we iterate through the pages. We extract the content and we pass it to the variable called the PDF text, right? We add it to the string, and we split the text into chunks. So we use the recursive character text splitter, and the chunk size is 1002, and we do an overlap of 50. So you can change that, and we create text variable, and we split that. We pass the text that we've extracted, we pass it in here, then we split that. So we use the split text to do that and create a metadata for each chunk. And we also create a Chroma vector stores, right? So we use the Nomic-embed text to do that. And we want to, so we create the embeddings and we create a vector store. So that is the Chroma. So we pass the text and create embedding for each of the text as well as their metadata. And we initialize the message history for the conversation. So we initialize it, we call it message history. And the memory for the conversational context, all right? So we want to add some memory capabilities. So the memory key is equal to chat history, output key is equal to answer. This is what we want to get. And we pass the message history into the chat history as the chat history. And we want to return the messages. So we call it true. And we create a chain that uses the Chroma vector store. So this is the chain. So we use the conversational retrieval chain, and we pass the model that is the LLAMA3 model, and we pass the chain type to be staff, and the retriever. This is what we are going to search our solution, our answers from the doc search, the vector store, and we pass the memory and return the document that is equal to true. So let the user know the system is ready. So this just make sure the system is ready for the user. Okay, so you can ask any question. All right, so we store the chain in the user. Right, so it means that it's ready. So the message starts between the user. All right, so here we retrieve the chain from the user section. Using the chain, we create a variable called chain, and we want that to happen parallel. So the user enters a question, you get the answers, right? So enters in parallel, and so we call it callbacks. So it happens in parallel. All right, so call the chain with the user's message content. So we call the variable called the res, and so we pass so in the chain, we pass the message content and the callback. And we want to get so here is called the answer. We want to get an answer. So we create a variable. So we initialize a list to store the text element, and we call it text element, and we pass a list, right? So let's process the source document. So if there's a source document available, what we are going to do is we want to iterate through that, and we create element reference in the message, and we append the content from the source as well as the name. Okay, so we want to append that. And what we are going to do now is we add the references to the answer. So we want to get the references when we get the sources as well. We want to add the references to it. Okay. Right. So if we create an if and else statement to do that. So if sources in there, we want to get the sources names. So else we don't have any sources found and we want to return the results. All right. So what we want to do now is so before we do that, we need to we want to pull the model. So we say Ollama pull. So we want to pull the model from Ollama. So Ollama pull LLAMA3. Okay, let's do LLAMA3. Let's pull it. All right, when that is done, we want to pull the nomic embedding. So we say Ollama pull nomic embed 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 text. Okay, so let's do that. Let's pull that. All right, when that is done, let me make sure everything is saved. Okay, so once that is done, we want to run it. So we run it saying Chainlit run app.py. So we are running the application here. This is the app.py, and we also have an image that we will going to display. So let's do it. So Chainlit run.py app.py. So when we run it, let's give it a feel. All right. So what we want to do now is let me upload a document to mental health. All right, so you see the image displayed here. Okay. All right, so let's see how it's going to come out. And it's a mental health document. It's being uploaded and it's processing. Let me just go into the document. Let me say definition of, let's try this one and see how the model responds. Let me put this here. I'm going to say what what is the definition of the concept of stigma? And let me hit enter and let's see how it's going to respond. All right, so we have a perfect answer. Actually, I like this response. So I'm saying what is the definition of the concept of stigma? According to the concept provided, the definition of stigma is stigma notion on the management of a spelled identity by Elvin Kaufman. All right, so it has the sources to it. So when you want to check the sources, they are here, which is awesome. All right, so I did it from this document and you can clearly see Kaufman here, which is awesome. All right, so let's try one more question and let's go for which one? Let me go for this one. All right, so let me just go for consequences of stigma. Close this one out. All right, so there are options to, if you want to expand, hide chain of thoughts, you can hide it. dark mode, light mode, right? I'm on the dark mode. Okay, so let me paste this one and let me say what like that are the consequences. Stigma, and just run it. See, right? Awesome. Yeah, so we have our answer. Comes out pretty nice. So the consequences of stigma can be far-reaching and devastating, affecting not only individuals but also. Wow. Okay. This is so great. All right. It is adding the sources to the document. Awesome. All right, guys. This is also I wanted to share with you. I hope you like this video. So let me know what you think about this model. Do well to subscribe and share and see you in the next one.